Anybody else want to guess? Andrew, you were saying Lemniscates. Is that right? Lemniscates. He's not going to go with the hard C. C. Anybody else want to take a stab at it? Let's find out. Hold on. Okay, ready? Let me turn my volume way up. You don't want to miss this.
Lemniscates.
Oh, you should have left it.
Lemniscates. 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 Lemniscates.
Yeah, that happens sometimes, though. Right? There's a lot of words where the I sounds like an A. Like compromise. Compromise. So that's an I, but it sounds like an A. No? I guess maybe you should say compromise, but nobody does, so I don't know. Isn't compromise? Compromise? Am I wrong? Is it compromise? No, I don't know how to spell compromise. This isn't math. Is it compromise? Oh, I'm right. It doesn't know. Well, I'm doing really well. Oh boy. Well, I'll come up with a different one. Mitch, I had Mitch. He hook, line, and sinker. He was like, good example. All right. So this one, why is this different than the other two, three? Yeah. R squared. It's not R equals. It's R squared equals, which is definitely tricky. We're going to, if you solve for R, you get R equals, and you have actually plus or minus 2, and then the square root of the sine of 2 theta. Is everyone good with that? The square root of 4 gives you a 2 out in front, and then the square root of sine 2 theta has to stay inside. Which becomes tricky because how do we graph that two-dimensionally? You really can't. We don't know how to graph the square root of things. So we're going to graph the 4 sine of 2 theta. And then we'll talk about how the R plays a role in a minute. And we can also do a table of values to kind of see this. But the sine of 2 theta starts at 0 and ends 1 period later, which the period is no longer 2 pi. The period is 2 pi over b, which is 2 pi over, we have a b of 2 here, yes? So the period is now pi, so it ends at pi. So a sine curve with an amplitude of 4 starts at 0, ends at pi. Amplitude of 4. But remember, we just graphed R squared. So our y-axis in this case, and this is the first time this has happened, is R squared. So when we go to look at points, R comma theta, and we start with this first critical point, which has a radius of 0, it's really R squared comma theta is what we're pulling from the graph. So if R squared is 0 when theta is 0, we then need to think about what would R theta look like. Now, if R squared is 0, what's R? Still 0, right? So that's still going to be the point 0, 0. The next one's going to be a little bit different. You have an R squared value of 4 at a theta of pi over 4. So if R squared is 4, this actually is going to give us 2 different points to look at. Agreed? Because if r squared is 4, r might be 2, or r might be negative 2. And then we're back to a radius of 0 at a pi, which is just still going to be 0 pi. And then we have another interesting section down here, because your r squared value is negative 4, so a radius of negative 4 with a, that should have been a pi over 2, shouldn't it have? 0 pi over 2, sorry. So this is going to be 3 pi over 4. And if r squared is negative 4, we actually don't have a corresponding r value. This is actually going to produce nothing. This entire negative section, when r squared is negative, is going to produce nothing on our polar graph. Because how can r squared be negative? We follow that? And so we'll come back to a 0 point. And so we just ended at a 0 origin point. We're going to pick up at a 0 origin point, which is 0 pi, which will still be 0 pi. And then we really are supposed to be doing these graphs right through to 2 pi. Because we had a shorter period here, we're actually going to have a higher frequency, and we're going to get 2 cycles in by the time we reach 2 pi. This part, though, is going to be negligible again, because your r squareds are in the negatives, which can't happen. So we just need to get to this point and then back to here. So this is 5 pi over 4, right? Halfway between pi and 3 pi over 2 is going to be 5 pi over 4. So that's a radius squared of 4 with an angle 5 pi over 4. And then your 4 will give you really an r squared of 4 will give you r's of 2 or negative 2. And then lastly, we're back at the origin or the x-axis, so that's 0 comma 2 pi, which is what it is. So this graph starts on our polar at 0, 0, which is obviously right in the middle. And then it's going to kind of divert into 2 directions. One goes to pi over 4 with a 2. So pi over 4 with a radius of 2. And that'll loop obviously through the first quadrant to get there. The other one is going to take our 0, 0 to that next negative point with a negative radius of pi over 4 with a negative 2, which throws us back into the third quadrant. Now, in the first quadrant, it kind of looped us. We were hitting the angles between 0 and pi over 4. So as we go down to this point, we're hitting the angles between pi and 5 pi over 4. So it kind of goes that way. Still counterclockwise, by the way. Everything seems to be counterclockwise, right? Because we go around the unit circle counterclockwise. But you have to make sure your inflection on that point is right. You don't want to wrap around the other direction, okay? So then both of them, regardless of which one we just went to, are going to come back to the origin. So if we continue this loop, we're back at the origin. And if we continue this loop, we're back at the origin. And the next point picks up at the origin. And then one is going to go to 5 pi over 4 positive 2, which we already have graphed. And the other one's going to go to 5 pi over 4 with a negative 2, which we already have graphed. So it's just going to really overlap itself here. Back to the origin, we're done. looks like an infinity symbol, yeah? I think the R squareds in general always look like an infinity symbol. Let me just show you the, yeah. So the R, here's really the two types. With the R squared, there's a coefficient, and then either the sine of 2 theta or the cosine of 2 theta. So it's got a period of pi in both situations. The sine ones are infinity symbols kind of diagonally oriented, and the cosine ones are infinity symbols oriented horizontally. So that is the expectation with lemniscates, is that they are diagonal. I don't think it has to be diagonal first and third. It could be diagonal second and fourth. I think. I have to think about that. But you should go through this process regardless. And this is the only time we really cross off a whole section of the graph, because R squared can't be negative. Makes sense? Okay. Try this one on your own. Okay. So I graphed my section, I crossed out my negatives. I'm starting with my first critical point, which is an r squared of 4 and a theta of 0. So that gives me two different r theta points, 2, 0, and negative 2, 0. So 2, 0, and negative 2, 0 will put me, and you can kind of already see how this cosine one is going to be oriented on the x-axis. And then they both come back to the origin. So counterclockwise back to the origin on both cases, counterclockwise back to the origin from both of those. And then from the origin, that's there still, we're going to go out to 4 pi, which is going to be 2 pi and negative 2 pi. So out to pi with a 2, and again going counterclockwise will bring me from here over here, and going counterclockwise will bring me from here to here. And there it is. Good? Easy? Hopefully. Okay, just a little new concept with the r squared there. So that's it. I'll let you do those 5 problems right now.